Hi, welcome to your 9-4 flip video. 9-4 is called solving multi-step inequalities. So just like how we had 8-4 and 8-5, which were solving equations using the distributive property and solving equations, multi-step equations, we have the same thing with inequalities. So these are basically inequalities that require multiple steps, more than two, in order to solve them. So these could be things like doing the distributive property, in addition to adding and subtracting or multiplying and dividing, or combining like terms and then distributive property and then other things in order to solve that inequality. So these are really the most complex inequalities we're going to look at, and they really require you to use all the knowledge from topic 8 and topic 9 so far in order to solve them. So I want to just do a quick reminder of how to flip around inequalities. So let's say I give you the inequality x is less than or equal to 7. Now, most of you prefer having the variable on the left, but some of you prefer it on the right. So regardless, this is the skill that you can use to rotate the sides of an inequality so you can get it in the system, the way that works best for your brain. So if you prefer the inequality on the left or you prefer it on the right, this rule helps you move the pieces around to get it to where you like it. So let's say I like that variable to be on the right-hand side. So I want to flip-flop the x and the 7. And so the 7 ends up on the left and the variable ends up on the right. But when I do that, you got to remember an inequality states a relationship between the two sides. So 7 is greater than or equal to x. X is less than or equal to 7. So when I flip the sides, I flip the inequality. This is similar to what we do when we flip the inequality symbol when dividing by a negative, multiplying or dividing by a negative number. So we're not actually changing the inequality, we're just changing its format to better suit our needs. So an inequality is true regardless of what side the variable is on, but I'm just giving you this tool to help you manipulate the inequalities to a system that is more comfortable for you. So let's look at some examples. So let's say I give you 80 is greater than 10 times the quantity b minus 23. So a lot of you don't like having that variable on the right. So I'll show you how to do it with both ways, and we'll see you get the same answer. So the first example, we'll leave it as it is. The second example, we'll flip-flop the order. So I changed the sides of the inequality. I rotated them, so I flipped my symbol. I changed it from a greater than to a less than symbol to reflect that change. So let's solve the left one first. 80 is greater than 10 times the quantity b minus 23. And let's not do the distributive. For this one, I won't do the distributive property. For the other one, I will do the distributive property, and it'll show you that you get to the same place no matter how you choose to do it. So if I divide both sides by 10, those 10s cancel out. 80 divided by 10 is 8, so 8 is greater than b minus 23. You're going to add 23 to both sides. Those 23s cancel, and you get 8 plus 23, which is 31. 31 is greater than b, which I can then transform into b is less than 31. Right? Because I flip-flop the sides, flip-flop the symbol. So I did that at the end because I think it's easier for you guys to recognize b is less than 31. So b has to be any number that's less than 31. So 30, 29, 28, whatever. If you do 31 is greater than b, some of you get tripped up and you say, well, what does that mean b can be? So I think at the end, having the variable on the left is helpful for you guys. If you guys are fine with 31 is greater than b, use that. There's no pressure to flip-flop it. All right. Now let's look at the second way you can solve this, which is if you rotate the sides, so it turns into 10 times the quantity b minus 23 is less than 80. And let's use the distributive property for this one. If you distribute that 10 times b is 10b, 10 times 23 is 230, minus sign holds between, and then all of that is less than 80. So now it's just a simple inequality. You're going to go ahead and solve it. You add 230 to both sides because we do PEMDAS backwards. We got to undo that subtraction first. So those 230s cancel out on the left-hand side, and you're left with 10b is less than 310. And then how do you get b by itself? You divide each side by 10. Those 10s cancel out, and b is less than 31. So no matter how I solve this, if I flip-flop the sides, if I do distributive property or not, I end up with the same inequality, the same equivalent inequality, which is that b is less than 31. So let's look at some 5 specific examples, and we'll walk through all 5 of them. I'm going to start with pink, work my way across, then go down to the next level, and then down to the last level. So 1/2 times the quantity y minus 6 is greater than or equal to 47. So for this one, let's not distribute. Let's divide each side by 1/2. So those 1/2s on the left cancel out, and I'm left with y minus 6 is greater than, but let's figure out what 47 divided by 1/2 is. So if I do that, 47 divided by 1/2, well, that's 2 fractions, 47 over 1 divided by 1 over 2. Keep change flip, changes into 47 over 1 times 2 over 1. And when you multiply fractions, you multiply numerator by numerator and denominator by denominator. So 47 times 2 gives me 94. 1 times 1 is 1. 94 over 1 is the same thing as 94. So 47 divided by 1/2 is the same thing as 94, which I can go ahead and plug in because I have on the right-hand side 47 divided by 1/2. So I have y minus 6 is greater than or equal to 94. So how do you get y by itself? Well, we're going to add 6 to both sides. Those 6 cancel, and you're left with y is greater than or equal to 100. All right. Move on into the green. Negative 5.2 times the quantity 8 minus r is less than 10.3. So, a lot going on here. Negatives, minus signs. Let's go ahead and break this down. So let's start by dividing each side by negative 5.2. And because I divided by a negative number, and remember, whenever you divide or multiply by a negative number in an inequality, you flip the symbol. So I always flip my symbol before I do anything else. So that less than changes into a greater than. And now let's work through the math. Those 5.2's cancel. I'm left with 8 minus r on the left. And now 10.3 divided by negative 5.2 gives me negative 1.98. And I rounded to the nearest hundredth. It keeps going a couple more decimal points. But for what we're doing, it's fine to round to the nearest hundredth. So 8 minus r is greater than negative 1.98. So how do you get r by itself? Well, I have 8 things, so I need to get rid of those 8 things that are interacting with my r. So I'm going to subtract that 8 from both sides. Those cancel out on the left, and you're left with negative r is less than negative 9.98, and that's because negative 1.98 minus 8 is negative 9.98. So now I want to figure out what r is. I don't want what negative r is. So in order to do that, I got to get rid of that negative sign. Well, what's that number hidden in front of that r? Well, that's negative 1r. So I'm going to divide each side by negative 1, and because I divided by a negative number, I have to flip my inequality symbol one more time. So that greater than changes into a less than. Now those 1's cancel out on the left. Negative 1 divided by negative 1 cancels out, so I'm left with r is less than 9.98. Another way some of you might find this helpful to work through, and I'm going to switch colors. Let's go yellow. If you go at this step, and I'll rewrite it right here, 8 minus r, I'm going to change that 8 minus r into plus negative r, and that's greater than negative 1.98. Now, I want r by itself, so let's use the property of addition that tells me that 2 plus 3 is equal to 3 plus 2, and this is the commutative property. Order doesn't matter in addition. So I'm going to change it from 8 plus negative r to negative r plus 8 is greater than negative 1.98. And now some of you feel more comfortable working with addition. So now I can subtract 8 from both sides. These cancel out on the left, and you get negative r is greater than negative 9.98, which is exactly what we got at this step right here. And then you can divide each side by that negative 1 for the same reasons we already talked about. Flip your symbol. I'm going to run out of room here. Flip the symbol. R is less than 9.98. So again, no matter how you choose to go about it, as long as you follow those rules, you'll get to the same endpoint, all right? So if you like adding the negative instead of subtracting the positive, you can do that. If you like distributing, you can do that. If you don't like distributing, you have that option. You can flip-flop the sides. You have a lot of freedom here on how you want to approach this. Let's look at that orange one. 20x plus 30x is greater than 1,000. So I see they both have x's. So let's combine like terms. 20x plus 30x gives me 50x. 50x is greater than 1,000. How do you get x by itself? You're going to divide each side by 50. 50's cancel on the left. X is greater than 20. So when you see like terms, combine them before doing additional steps. When you look at the blue, you got 5x minus 3x plus 1.2 plus 11x is less than or equal to 19.2. So again, you have multiple terms with like terms within it. So let's combine those. So you have the 5x. I'm going to change that minus 3x to plus negative 3x, because then they're all addition signs, and you guys seem to like that better. So then I have 5x, negative 3x, 11x, and then that 1.2 is in its own category. So I'm going to combine all the x's. So 5x plus negative 3x plus 11x gives me 13x. And I plug that in, 13x, and I have that plus 1.2 still there, is less than or equal to 19.2. So how are you going to get x by itself? PEMDAS backwards. You're going to subtract 1.2 from both sides. Those 1.2s on the left cancel, and you're left with 13x is less than or equal to 18.2. Now I don't want to know what 13x is less than. I want to know what x is less than. So I'm going to divide each side by 13. 13's on the left cancel, and you're left with x is less than or equal to 1.4, because 18.2 divided by 13 is 1.4. Final example, we have the purple. You have 5 times the quantity 3x plus 2 minus x is not equal to 11. So I'm going to distribute. Another option you have is you could combine like terms before you distribute. And so you could do 3x minus x gives you 2x, so then it saves you a term. I'm not going to do that because I want to get for you guys the practice of seeing the distributive property with more than 2 terms. So I'm going to distribute that 5x, that 5 times all the pieces inside. So 5 times 3x is 15x, 5 times 2 is 10. There's a plus sign between the 3x and the 2, so there's a plus sign between the 15x and the 10. 5 times x is 5x, and then there's a minus sign between the 2 and the x, so there's a minus sign between the 10 and the negative 5x. Or the 10 and the 5x is not negative, there's a minus sign. And that's still all not equal to 11. So let's combine like terms. I have a 15x and a minus 5x. 15x plus negative 5x gives me 10x plus, and I have that plus 10 still. So 10x plus 10 is not equal to 11. And I'm going to subtract 10 from both sides because I want to get that x by itself. The 10s on the left cancel each other out, and you're left with 10x is not equal to 1. I want to figure out what x is not equal to, so I'm going to divide each side by 10. 10's on the left cancel. X is not equal to 1 over 10. So what does that mean? That means x can be any number except for 1 over 10. It could be 2 over 10, 3 over 10, 100 over 10, 10 by itself, a million, negative a million, any of those. It just can't be 1 over 10. So on a number line, we can go ahead and show that. And we do that by identifying the 1 over 10. So 0.1, I use decimals on this, but I know that 0.1 is the same thing as 1 over 10. So when I identify the 1 over 10, it's 0.1. So right there, and I know x can't be 1 over 10. So I represent that with an open circle, but x can be any other number. So I shade everything to the left and everything to the right. And that gives me a number line where every number is a possibility. It's shaded in except for 1 over 10. So the number line that represents x is not equal to 1 over 10 is just a number line completely filled in with a hole at 1 over 10. All right, this is it for 9.4, and that is all the new information we have for topic 9. Let me know if you have any questions.